All right, thank you for joining Clinical Guidelines with FHIR and CQL. My name is Bryn Rhodes. I'm the CTO for FHIR. I'm also a co-chair of the HL7 Clinical Decision Support Workgroup, where a lot of the standards that we're going to talk about today are stewarded. And I'm generally a standards editor, sort of what I do most of the time. So learning objectives, we're going to hopefully understand the FHIR CPG approach to computable clinical guidelines, be able to explain what a FHIR CPG is, understand feedback loops. I don't think, anyway. Know what tools and technologies are currently available to help implement and author and distribute FHIR CPGs. And know where to look for additional resources if you have more questions. Typically start talking about this by looking at the quality improvement ecosystem. We've also kind of heard maybe this talked about as like a learning health system or continuous quality improvement of healthcare. Starts with research where we try to identify, analyze what's happening, synthesize that research into best practices to determine what should happen, try to make that happen however we can at using clinical decision support, ideally impacting positively the clinician and patient workflows, and then measuring what happens in measurement and analytics, and finally reporting on that. And ideally that forms a continuous improvement cycle. So there are lots of different stakeholders exchanging lots of different, do you have a question? No, you're fine. It just looked like your hand was up, so okay. Lots of different stakeholders exchanging lots of different kinds of information around this quality improvement ecosystem. It basically represents the entire healthcare industry. And so naturally there are lots of specifications. This is just within HL7 and just a kind of a subset of the standards that are related to trying to capture and enable exchange of information across these boundaries. So I'm going to talk specifically about CPG IG, which is Clinical Practice Guidelines Implementation Guide. But I'm putting it in this context to recognize that it's taking advantage of the work that's being done in US Core and Clinical Reasoning Module in FHIR and QI Core, Public Health. We're actively engaged in each of these projects to try to bring together the representations that are used for this kind of information and make sure that we're sharing them in the same way in all of these different spaces. So with that as background, the question is why? Like overall, why are we doing all these things and trying to standardize all these spaces? And ideally, we're going to reduce the development effort required for clinical systems to support evolving standards of care. So it's hopefully a pretty non-controversial statement, but it's also like a huge problem with lots of different facets. And so we're obviously not going to tackle all of it at once. And so what we're trying to do in this particular space is focus on the how we can help achieve that by enabling precise and unambiguous sharing of clinical knowledge. So how do you share that best practice guideline? It's a smaller problem, but it's still not a small problem. It still has lots of facets and lots of challenges associated with that. So thankfully, we can leverage a lot of different types of interoperability to help us get there. So across a kind of spectrum of interoperability, from data to knowledge, we have different types of interoperability within that. So this is a continuum. None of these are discrete, and there are kind of fuzzy boundaries around each of them. But lexical interoperability is like we're sharing the same tokens, right? When we're on the same code page, and so we can share the same tokens. It's like ASCII files, right? Syntactic means that we're sharing the same structure. So we're using JSON and we have the same structure on both sides. Semantic then builds on that to say, okay, when we have an element in that structure on both sides of that exchange, both systems understand that code means the same thing to both systems. And that semantic kind of starts bridging into the knowledge, where we're starting to actually share knowledge, like what a data element is versus just the data that's involved. And then we build on that to say logical interoperability is now that I can share data and semantics of that data, then I can also start to share expressions on that data. So that when I say the value is greater than 10 milligrams of mercury or millimeters of mercury, I get the same answer on both sides. So I can actually start sharing expressions. And then process interoperability says, if I have logical interoperability, then I can share actual processes. We in the kind of CDS and CQI space are focused on this logical interoperability space. And a lot of the clinical guidelines IG is about enabling that sharing of logical expressions. So first, how do we get to data interoperability? We look at, obviously we have to choose a way to do that. And we think FHIR is obviously the right way to do that. So FHIR, this is a FHIR conference, so you probably already know all this, but it's broken up into modules. There's a foundational module and conformance and administration and clinical, and then there's this reasoning module. So the resources are the building blocks. So the things that are, generally speaking, they're providing the syntax. They don't provide semantics. That to get to that level, you need to actually define profiles where you're saying on both sides of an equation, what are the semantics involved in the exchange? And then protocols that define the interactions. So that those things together make up FHIR as an exchange framework. But it's very general and it's universally applicable. And so we have to profile it and provide implementation guides to say how we would use those things. So in thinking about sharing logic, we make the separation between the model and the terms and the logic. This follows that same kind of syntactic, semantic, and logical interoperability. So on the model side, we're saying what kinds of things can we talk about? Encounters have this structure and medications have that structure. On the terminology side, we're using standardized terminologies like SNOMED and LOINC and RxNorm to say that we mean the same thing on both sides of those of that sharing. And then by using that, rather than trying to define it, we're able to separate and share that logic. So that as a pattern, another pattern that we use is this knowledge levels. So when we talk about sharing knowledge, this is a framework for describing different levels of representation and how computable the knowledge that's represented there is. So L1 says this is just narrative content. It typically requires a human to interpret it. And you might see things like, a peer-reviewed journal article. Most guidelines today are at least at this level. L2 is semi-structured, where you start to get into flow diagrams and decision trees, so things that aren't quite computable yet, but they're providing more structured information. L3 is structured, where we have a standards compliant specification encoding logic with data model, terminology, and code sets. So you have a fully computable, but importantly, it's a platform independent representation of that content. And finally, L4 is executable, and that's like running code in a running system. So it's platform specific, it's implemented, it's used in a local environment, so it's mapping to specific codes. So that's L4. Now, if you look across those levels and you put that on the kind of 3 tiers of kind of classic enterprise architecture, with the data tier at the bottom, a forms tier at the top, and a kind of application tier in the middle, then at each of those different levels, there are different kind of artifacts that you can talk about. Like L1 in forms is a paper form, right? Or a user story. L4 in executable is a running application on your phone that's showing you a rendered form. What we focus on in CPG is this L3 structured artifacts, and how you represent the L3 in a platform independent way, ideally to streamline getting applications developed that take you all the way to L4. So I'm going to talk more about each of those, but what we identify in there in that kind of L3 column is some key interoperability resources in FHIR. So on the model side, you have structure definition and structure map. These are, again, pretty vague categories, but it's useful to kind of think of them in these terms. The model is giving us the syntax. The terminology is giving us the semantics. In the terminology resources, you've got code system, value set, and concept map. And in the behavior side, you have library, questionnaire, activity definition, plan definition, and measure. These are patient-independent artifacts that allow you to represent behavior within FHIR. So I'm going to walk through some examples of applying this using some opioid-related projects. These are different projects that are all based on CDC 2016 opioid prescribing guideline. There's an opioid prescribing IG, which is a CPG for all 12 recommendations in that guideline. There's an ARC pain management summary that's kind of a smart on FHIR application that provides cognitive support for the 2016 guideline. There's an opioid ECQM, and there's an ARC chronic pain management that provides shared decision-making for chronic pain management. We're going to focus on the opioid prescribing IG, but just recognize the context here is that these are all different artifacts that are derived from that same guideline. So we'll start by recognizing that, that kind of goal is CPG, the reason for its existence, if you will, is to get to a structured representation of the guideline recommendations such that you can streamline the executable implementation of those. So we start with looking at L2. This is recommendation 11. Clinicians should avoid prescribing opioid pain medication and benzodiazepines concurrently whenever possible. There's kind of a functional description there. This is getting to break down more semi-structured information. Still not computable, but it's pseudocode, if you will, right? And this is clear and readable, but it's less ambiguous than just the narrative text. And it starts to kind of identify when these things are happening, so pinning it to a workflow, and it starts to contextualize what's actually going on when the provider is prescribing an opioid analgesic. Is opioid review useful for this patient? And this provides a flow diagram that helps communicate visually what the recommendation is and how it would be integrated into actual workflow. So this is a lot more information than just the narrative description of the recommendation, and it's contextualizing that in kind of from an informatics perspective. It's also identifying the data elements at a very high level. So the first thing we look at is this terminology and data elements, given the code system, the value set, and the structure definition and measure. Start with just a brief overview of terminology and how that's actually shared in FHIR. So there's a code system resource, represents a single system of coded concepts. It's not intended for distribution. It's kind of a description of the code system and its properties. May contain content, but not necessarily, or maybe even partially. It may be enumerated, or it may have a formal grammar. So a code system can be just a list of codes, or it can be like a grammar for actually generating codes based on a set of rules, or it can be both. A lot of them have both lists of codes as well as rules for generating new codes. The key point about a code system is that it's a single namespace of codes, and it can be validated. It's always possible to tell, given a specific code, whether it's a member of that system. That's like the key important aspect there. It can also have associated properties like hierarchies and grouping, but that's the code system resource. Super important resource for sharing terminology. Next is the value set. And a value set represents a collection of codes from one or more systems. A value set as a resource can have a definition and or an expansion. And there are different reasons for having both and wanting both and using both in different scenarios that come into play. So the definition is instructions for how to build the contents of the value set, like it's the membership criteria. And then the expansion is an explicit listing of the members of the value set. And it's important that it's an explicit listing at a particular point or with a particular set of parameters to the expand. And we'll get into that a little bit more later. I went backwards. I don't know how I did, but I did. There. All right, so the value set definition comes in two flavors. It can be intentional, where it's defined in terms of expressive criteria. So give me the code diabetes mellitus and all child codes recursively. Or it can come in an extensional flavor, where it's just an enumeration of codes. Give me diabetes mellitus type 1. And for a given version of the SNOMED code system, the intentional and extensional definitions might be exactly the same. But for different versions of the code systems, they might be different. The point of the intentional is to try to capture the kind of meaning of that value set, rather than just explicitly listing the codes, where if a new code for diabetes is added, you have to go add that into your value set. So that's the reason for the intentional versus extensional. I will say at this point, most of the value sets that we see are extensional, but we're starting to see a lot more intentional, and that intentional is a more manageable way to actually share and manage that content. So we try to enable the use of intentional value sets. But the challenge there is that, as I said, you've got the different versions of SNOMED that are going to have different versions, different codes where it's a diabetes code. And so the expansion of that will change depending on what version of the code system you're using. But the meaning of that value set remains the same. It's diabetes mellitus. So we call that in this space, we call that a computable definition and an executable representation. Those are that's white on gray, so you can't see that at all. But yeah, the one over here says computable, and the one that's all right, I'll fix that. But that's an important factor in the packaging that we'll talk about later. So as an example, opioid analgesics with ambulatory misuse potential. This is actually a content logical definition where we're listing out the codes. Because we didn't have intentional representation, an authoring system that could support it, we actually just did this extensionally, and so stuck all those codes in there. But ideally, we would express this in terms of an RxNorm query, right? So we're working on that in this particular case. But this is just an example of terminology in that CPG. Next is the data elements. Structure definition is the underlying resource for describing both resources and profiles in FHIR. So every structure definition represents either a resource or a profile. Every resource has the base structure definition, then every profile comes along and says what the differential of that profile is from the base, either profile or resource. And so in a structure definition, you'll see there's kind of an analog of the intentional and extensional in value sets, or the compose and the expansion, in that resources have both a snapshot and a differential. And that differential is how you compute the actual result, and the snapshot is the kind of expansion, if you will. So there's that same kind of computable versus executable in resources and their definitions. The key is that the profiles are giving more and more constraints and meaning to the data that you're actually sharing by binding elements to particular value sets and providing those constraints about what data are valid. So each element describes the name, the type, the constraints, and the binding, which is actually a reference to a value set. These are definitions that are independent of a specific patient. They're independent of a location. They're independent of time, and they're largely independent of related information. So the profiles are a way to characterize a data element, but in order to actually use that data element, like here's a flexible sigmoidoscopy data element. It uses FHIR as a data model. It's expressed, i.e. it's expressed in terms of a FHIR resource. It references terminology. So this is via the concepts library for flexible sigmoidoscopy. There's a value set there. And it establishes some expectations for values like invariance. So the status has to be completed. So it's an example of a flexible sigmoidoscopy performed as an example data element. But to apply that data element, it needs to be contextualized. So it can be contextualized in different ways, like a particular patient or an encounter or a procedure. This is equivalent to the context in CQL. It can be contextualized temporally, so to a point in time or a period of time, like a measurement period. It can be contextualized to a location or a particular user, or even a relationship, like for a related encounter or procedure. That same data element can appear in lots of different places based on the different context that you need to apply it to. So for example, flexible sigmoidoscopy performed within 5 years. So we take that data element and we add a criteria to say that its performance interval is 5 years or less on or before the as of, which is like a parameter, a point in time parameter to that logic. You can then say the most recent flexible sigmoidoscopy performed using that most recent function that just takes all of them and sorts it and gives you the most recent one. And those are examples of contextualizing a data element in different places and different use cases. And you can have even more complex data elements like has appropriate colorectal cancer screening, where you've had a fecal occult blood test within a year, or a fecal immunochemical test, and so on. So those are pretty high level, but the point is the data elements can be very low level, but they can also be high level combinations of other data elements. The way that we share that within a CPG, this is an example from the CDC opioid prescribing guideline. This is a medication request, and it just builds on the CPG medication request and provides must support for the elements that are required in order to perform the calculation that's done in the IG, which in this case is a MME calculation. So basically this is saying in order to perform an MME calculation, I need the dosage instruction, I need the timing, the repeat, the frequency, the period unit. Otherwise, if you don't give me that information, the calculations that I've written in this logic are not going to work because I don't have the data that I need. All right. So then we look at sharing logic and rules. This is the logic for the recommendation 11. Patient is being prescribed opioid analgesic with ambulatory misuse potential, or the patient is being prescribed benzodiazepine. So if you have either of those situations, then and an opioid review is useful, and there's not exclusion criteria, then the recommendation is applicable. So basically, this is a completely platform independent but formal representation of this flow diagram logic in terms of data elements that we can share with FHIR structure definitions and value sets. The recommendation itself is represented with a plan definition. So there's an event condition, basically it's an event condition action rule. So the event says when I'm prescribing, the trigger there is on the next page, but the action here is the existing patient has concurrent opioid and benzodiazepine prescriptions. The description is checking if the trigger prescription meets the inclusion criteria for recommendation 11 workflow. This is where you link it back to the guideline to provide the source for that action and the documentation of whether this is a strong recommendation and what the quality of evidence is. If you remember back to that, to the description of the recommendation, they had categorizations of the evidence and strength of the recommendation. So this is where you actually represent that. And then the trigger in this case is a named event for order select. And so when an order select event occurs, the condition for applicability here runs. It's actually a reference to his recommendation applicable in that library we just saw. And so that just runs all of that logic, which applies to the patient data and gets back a yes or no, plus additional detail that's coming back about what the recommendation said. So that get detail and get summary are also expressions in that library. So the key here then is that you take all of these things, you put them into an implementation guide, and now you have distribution of that content because these are all just FHIR resources, just like any other FHIR resources. So you have an implementation guide that is a FHIR CPG by virtue of the fact that it contains these representations of all the recommendations. So for each of those recommendations, there's a page in the IG that describes that computable content. And further, you can share those implementation guides just like any other implementation guide. In this case, if you look at this MME calculation one right here, we refactored the MME calculation out of the opioid IG so that we could use it in the decision support as well as an ECQM using that same logic. So in the same way, we've abstracted the core data elements out of some of the WHO content so that family planning and sexually transmitted infection and antenatal care can all reuse some of the same core data elements across them. So the fact that it's an implementation guide lets us plug into that FHIR publishing ecosystem and the FHIR distribution ecosystem there. And you have service-based integration via CDS hooks. This is one of the delivery mechanisms for a FHIR CPG. So you've defined the order select. That plan definition says when an order select fires, I need this information. So we can expose that as a CDS hooks API with prefetch templates to say what data we need, and that then ships data over. Then we can run that plan definition on the data that came through in the request and turn that back into a response. So in this opioid prescribing IG, I have not only a workflow and a description of everything that it should be doing, but it's actually computable if I have a clinical reasoning engine that can actually run that content. So I just take that bundle that came out of the implementation guide and I post that to a clinical reasoning server that is exposing that via CDS hooks, and you can actually make that call and get that evaluation done. So that's actually getting it all the way to L4, but I only built L3 content. We've also reused that. So here's another example of the benefit of these things being in IGs. The opioid prescribing guideline has all of the value sets associated with that were developed for that project. There's a CDS for CPM implementation guide that's able to take that information from there, as well as the VSAC terminology that the original opioid pain management summary had defined. But now we have to take all of these 3 different terminology sources and pull them into the same packaging. If we put these all into the same implementation guide, we can do that pretty easily, but there are kind of limitations around whether I can actually share that terminology, and so I actually have to be able to pull from different sources. But in the actual deployment, the engine that runs the logic in the pain manager application needs those in a particular format. So we pulled them all from these different sources, we ran them through some tooling to get them into that same format, and then shipped them off to be run as part of a JavaScript application. So that was one we basically had to do a one-off packaging, and I'm calling that out because it was a particularly painful aspect of that project. And it's something that I think we really need to improve. So one of the things we're working towards identifying is more addressing this kind of value set expansion, because the challenge is not only was that a one-off process that had to go through to get that terminology deployed, but in the time that we got that finished, all of the code systems that we were using had published again. And so, just getting to that point, they were already stale. So clearly we need better tooling around this. Just coming back to this value set expansion problem, and how do we actually, let me set that within a particular artifact value set usage. So if we think about a particular measure, as you're authoring that measure, you're pointing to a particular version of a value set. And SNOMED is trucking along and publishing, and that cycle of actually building that measure typically takes longer than the publication cycle of SNOMED. So you're already outdated by the time you finish developing the measure. So what you have to do is kind of say, okay, well, during the authoring period, we'll take whatever's the latest version. And then when we release, we'll say, okay, but you have to run this value set with this particular version of SNOMED. It gets even worse because every year you start doing new measures that actually use some of those same value set definitions. And then there's a new version of SNOMED that you're developing against and then releasing against. So this is and you can imagine when you have multiple measures with multiple value sets, this problem gets worse and worse. This is just one measure and one value set. So option one, which you cannot see, is to pin the version in the value set. So you can say, okay, well, we'll pin the version of the code system in the value set, but then I have to actually change. What that means then is I have to actually update every value set that I'm using to talk about the new version of SNOMED every time there's a new version released. It's just untenable in terms of value set versions and definitions. It creates significant maintenance and it limits the resulting reusability of that value set. It also means artifacts would have to reference specific versions of the value set, and that alone would create significant value set version information in the artifacts. Option two is to pin the value set version in the measure, but that means a new version of the artifact, even though nothing really changed. All I did was say, I want to use this new version of SNOMED. And again, that limits the reusability of the artifact. So what we'll propose is that there's a version of the artifacts and dependencies that you specify in a separate file, in a manifest. So you say, these are all the dependencies of this artifact, traced all the way through. If I have a value set that's grouping, then I'm tracing the grouping value sets all the way through. So I collect all those dependencies and I say what all the versions of those dependencies are. And I pin those in a manifest, and that's independent of the value set definition and the artifact definition. So I'm not having to version those and maintain that. Then I pin that, and as I release, I choose whether or not I want to take new versions of SNOMED that have been published. And then I publish that set of artifacts with that manifest. So we do that using an asset collections. FHIR has an asset collection library that allows collections of related artifacts to be described together with parameters for how they should be used in particular contexts. So other names for this are version manifest. The VSAC currently has a thing called an expansion profile that is basically this, and quality programs and quality program releases. And the key here is that because a CPG ends up being a collection of artifacts that have dependencies on either other IGs or significant sets of value sets that are intended to be reused across different use cases, we have this problem in every CPG that goes out. And so,
question, are the manifests only additive?
They're only additive. So you're saying this is a set of things. If you wanted to replace, it's a good question. You have to think about it. But if you wanted to replace a dependency, but the idea is that you can override a version as well. So if your artifact says, I actually want this version, then the artifact wins, right? If the artifact has a reason to actually say, I really want this particular version, then it can do that. And the manifest is only providing, versions for where it's not pinned in the artifacts themselves. No, I think there's just a phone going off. 10 minutes left?
10 minutes left.
Oh, I got through it all. Okay, fair enough. I guess I started talking quicker than expected. All right. So let's see, go back to that slide. So the key there is that a FHIR CPG is a kind of content, a kind of FHIR implementation guide that's focused on delivering libraries, value sets, profiles that describe recommendations for clinical guidelines in a computable way, and that can be delivered and either streamline implementation or via reference implementation actually provide a direct implementation. And can be delivered as a guideline, as a FHIR IG. And there's, in the Java space, this slide has links to all of these different components. So these are just open source components that can be used to either help author these things, kind of package them, or distribute them as well. So it starts with the CQL translator, which is a CQL to ELM translator. The engine that actually can run the output of the translator. So that's the actual expression logic. There's a language server that wraps up the translator and exposes those capabilities to the VS Code plugin. So you can actually, in VS Code, run, author CQL and execute it and test it as you're going. CQF tooling is a grab bag of tools for helping publish, and then the evaluator pulls all those things together and actually does evaluation of CQL against FHIR in different contexts. And then we have extensions of the Happy FHIR server that can take all these components and run this content inside a Happy FHIR server. This is, if you're going to the Let's Build session next, this is the stack that we'll be using to do that. And in particular, we've got it pulled into a code space so that in GitHub, you can just open this code space on a repository, and you have basically an IG editing and authoring environment where you can write your CQL and test it and package it up, turn it into an IG, and then deploy it to a running sandbox if you so desire, which is what we're going to do in the next session. So that is it. A bunch of links if you want to get involved. There's Adapting Clinical Guidelines for the Digital Age. That's a CDC initiative that is basically the output of that initiative is the CPG on FHIR implementation guide. There's the Quality Framework Initiative, which is within a joint project between CDS and CQI. There's WHO Smart Guidelines Initiatives, which there's been several sessions about that this round. And then there's EBM on FHIR. There's also the CQL FHIR Zulip stream, CQ Framework Repository, where all the source code for all those components lives, and the ECQI Resource Center, which is about ECQMs. So hopefully by the end of this, you can answer some of those questions. What FHIR CPG is, I don't know, maybe complex. Yeah. Well, so is a clinical guideline. So FHIR CPGs can be authored and published as FHIR implementation guides using FHIR Clinical Reasoning Resources. FHIR CPGs can be implemented by plugging them into CDS Hooks services. And open source technologies are available to implement these things. So during DevDays, you can reach me here. There's also CQL stream, I'm active there. And that's my Zulip chat. So questions?
Hey, Bryn, I was wondering, although not one for one, like implementation guides and FHIR packages kind of go together. And there's dependencies in kind of that whole ecosystem, FHIR packages. But then we also have like in the measure space, like the package operation, which sounds similar, but is different. Do you have thoughts on kind of that kind of packaging and Are they in tension or compatible?
Yes. So the tooling here, the package operation is intended to support building packages that are targeted at particular environments. So would not be one-to-one with the IG. Like you might have the same content that you want to deliver into different spaces. And if you're delivering it into a space that has a full-blown terminology server and is capable of expanding value sets, you might want to deliver the computable representation so that it can do the expansion itself. But if you're taking that content and delivering it to an Android phone that you expect not to have a FHIR terminology service, you need to deliver the expansions as part of that. And so the package operation is a way to let you use that version manifest to build up and the, asking for computable versus executable content to build up packages that can be deployed in different spaces. So the package, and in that, the result of a package there is actually just a FHIR bundle. And so, yeah, that package operation would not be expected to be one-to-one. And the tooling here that we, when you run that on an IG, it creates a bundle per artifact in the IG, but it actually puts it outside the IG. It doesn't put it in the IG for that reason, because it's a package that's basically an authoring package. It can be used to deploy into a reference implementation, but in a production scenario, you're going to want packages that are targeted at your specific environments. Does that help?
Hey, Bryn, this is probably an ignorant question, but what does production use of this look like in terms of like what types of applications are communicating with what other types of applications? So like, I think you're describing this, and the intent of the infrastructure is both to do clinical quality measure calculation, right? But then also like clinical decision support, like through the use of an API like CDS hooks. And so in both cases, like data is coming from a EHR, clinical data repository, or something like that. Do you anticipate that, like with production use, when we've got CMS or CDC or other kind of like clinical guideline authoring bodies publishing and distributing guidelines in this way and quality measures in this way, like who's actually going to be running this infrastructure?
I think there's just like the kind of profile validation and profile development and services that are issuing or that are responding to requests for profiles. I think there's going to be N infrastructures, and that's one of the reasons that I think that the representation as a platform independent description of the behavior is super important, because you're going to have that same logic need to be run in a Spark data pipeline that's doing quality measurement processing, and an Android phone that's doing decision support logic based on that same CPG. So the machinery that will actually run it depends on the use case that you actually get, that you actually see. Like with ECQMs right now, they're distributed, and they're distributed as computable platform independent representations. Then they're run in a variety of different infrastructures, right? They're run, some of the EHRs actually take them internally and ingest that content and run it locally on their systems. Some of them have reporting vendors that take the data, extract it out, and run it in a pipeline of their own. And some actually incorporate into decision support and run it that way. So it's the same idea there, but we're currently not able to share at that level. It's just by mind share, right? You have the description of the ECQM, and then a developer goes and makes that happen in those different environments. And the goal is to get the behavior computably shareable to the point where we don't have to have that repetitious coding every time. Did that maybe answer a little bit of it? It's an excellent question, and it's really gets to the heart of it. Yeah.
Okay, we are at time. So if you do have additional questions, you could contact Bryn the way he had mentioned on that last slide, or enter a question into the WHOVA Q&A for this session. Bryn, please check back, in that area in WHOVA for any unanswered questions, because those questions in that Q&A session do stay there for, as long as we have access to WHOVA. So that's an excellent way to ask a question if you still have one here. Thank you. Standing room only for you. Oh, bad, because I didn't notice that many people were sitting there. I could have gone over there and said, "Hey, there's seats here for you." So,
Right.
I need to. It's on there, and that's a good thing, because this is where we're trying to go.
Okay.
And
I thought I was getting in trouble.
No. So
I cleared that.
No. So we need, and we can do this, post conference.
Yeah.
You still have an active contract with us, right?
You're gonna need to talk to Mike. I don't know. Honestly,
well, let's assume we do, because we may need to help with this. We may need to get into nuts and bolts, but
yeah.
But we need to figure out, we need to map out how we take one or more HEDIS measures and get it into one of these CPG IGs, and mock up something that we could do some clinical decision support with, and also some annual measurement. Matt has been trying to guide our knowledge engineering team to this.
Right.
Frankly, I think we'll do a better job. We are struggling to try to put specifics, right? Specifics. What resources do we have? What tools do we use to turn this to this to this? Right. We just need a roadmap. Okay. Based on what your talk just was, I think you can deliver that to us. We desperately need that.
Okay.
So I will talk to my people. We'll be in touch.
All right. Good. Thank you. Appreciate it.
I gotta run, but got time tomorrow.
Yeah, I'll be around tomorrow.
Okay.
Yeah, send me an email on something on the schedule.
Okay.
Yeah. Shut up.
Question, there was for your other talk, you wanted email. I haven't done it yet. Like for giving access
to
the
GitHub.
person.
Yeah, GitHub.
Can I email, or can I just give you my?
Yeah, just GitHub. We'll get you added.
Method MIT. It's my first name with 008. Yeah, this one, sir.
I believe it is. Okay. If I'm wrong about that, please let me know.
Let's see. Yeah.
Why isn't that coming up? Am I not on the interwebs?
You're connected so far.
Can't reach the page. That's really going to hurt for my talk if